This video looks at the concept of an angle of depression, and as the name suggests, it refers to the angle formed when an observer at some elevated point above a ground level or some base level is looking downwards at some point or object below the observer's elevation point. So I'll illustrate what an angle of depression is. So say this is some high point. Let's say this is a ladder. Imagine someone standing here at point A. The person just looks straight ahead in this right direction. So you just look straight ahead. The line of sight is this dotted line. This is the person's line of sight. Now, if the person now decides to look downwards at an object B on the ground, the line of sight is this diagonal line of sight. Now, the angle formed between the horizontal line of sight and the actual line of sight, because the person is looking downwards, is this angle here, and it's known as an angle of depression. It's the angle of depression of point B from A. From A because we're looking from A at point B. So it's the angle of depression of point B because you're looking at point B from A. And the angle of depression is the angle formed between the horizontal line of sight and the actual line of sight when the observer at the elevated point is looking downwards at some object or point on the ground or whatever base level just below the observer's position. Angle of depression problems take the basic form where there's an object or point on a base level such as the ground. So you usually have a flat or horizontal ground level, and you have an object on that ground, so I'm just call that object B. And then you have a tall object such as a tree or a tower or a building. So just some tall object, usually vertical. And then you have an observer at the top of the tall object. And the observer will be looking down at the object on the ground. So this would be the observer's line of sight. Now, if the observer decided to look horizontally straight ahead, this would be the line of sight of the observer. The angle formed between the horizontal line of sight and the actual line of sight when the observer is looking downwards at the object on the ground is the angle of depression. Next, I'm going to illustrate a simple idea which just involves basic geometry, but you're going to find it very useful when solving angle of depression problems. Now, if you recall, in the angle of elevation video, you saw that the scenarios were always represented by right angle triangles. Same thing is going to happen with angle of depression problems, but it's going to be very useful to note that if you have a right angle triangle, if you extend a line from this point, a vertical line downwards, and you extend a horizontal line from this tip here, you form a point D. So I'm going to call that point D, and the length of AD is equal to the length of BC. Essentially, what you formed is a rectangle. Opposite sides have equal length. So AD has the same length as BC. BA has the same length as side CD. So you need to note that. So I'm just going to highlight BA and CD have the same length, and side BC and AD have the same length. So we started a right angle triangle, and what we formed was a rectangle. I know for a rectangle, opposite sides have equal lengths. Now, just this simple basic geometric idea is going to prove very useful in simplifying problems involving angles of depression. So here's the first example question, and it says a boy is standing at the top of a tower. So that point which he stands at is point A, and is looking down at the point B on the ground. The tower is 200 meters tall, and the point B is located 200 meters from the base of the tower. We're required to draw and label a right angle triangle representing the given information. So for the first question, we just use the description to sketch a right angle triangle. We have a tower here, and a boy is at the top, point A. There's a ground level, and there's a point B on the ground level, and it says that the boy looks down at the point B. So I'm just going to draw a line of sight for the boy. The boy is at A and he's looking down at the point B. So this is the line of sight of the boy. So essentially, what we have here is a right angle triangle because the tower will be taken to be vertical and the ground level is horizontal. Vertical and horizontal lines form right angles between each other. They are perpendicular to each other. Anyway, moving on, the tower is 200 meters tall. So if I call this point C, the length or height of side AC of this right angle triangle is 200 meters. And it says the point B is located 200 meters from the base of the tower. So the base of the tower is this point C. B is 200 meters from the base of the tower. So this side is also 200 meters. So we have a complete right angle triangle. Question 2 says determine the angle of depression of point B. The angle of depression of point B from A. So you're at A, you're looking down at point B. What's the angle of depression? Well, if you're looking straight ahead, this will be your line of sight, but you're actually looking downwards. The angle formed between this horizontal line of sight and the actual line of sight in blue is the angle of depression, which I'm going to call theta. And remember, you can form a rectangle. So I'm just going to extend this line here and extend this line upwards. I'll just form the rectangle. I'm going to call this point, call it D. And as you know, the line AC has the same length as the side DB. So this is also 200 meters. CB, side CB has the same length as the side AD, so this side also has a length of 200 meters. So I'm calling this point D and C. So I'm just going to move to a neater diagram because we need to determine the angle of depression of point B from A. You're at A, you're looking out at B. So we need to find the value of this angle theta. So here is a neater sketch. We have the point A here, point C, the base of the tower. We have point B here, and we have point D. So this is just, you can see the outline of a rectangle which formed, but initially we just had this right angle triangle ABC. So we need to find theta. If you just focus on this triangle here, which is also a right angle triangle, remember we formed a rectangle, and you know that all the sides of all the angles of interior angles of rectangle are right angles. So you can see why this is also a right angle, and this triangle highlighted in black is a right angle triangle. There's this triangle ADB or ABD, whichever one you want to call it. And we're looking for this angle here, theta. Well, clearly you can see that the opposite side to theta is this side with a length of 200 meters. So O has a value of 200 meters. The hypotenuse is this side, and the remaining side is the adjacent side to angle theta, which also has length of 200 meters. Now from SOHCAHTOA to R, the tangent of angle theta will be equal to the length of the opposite side divided by the length of the adjacent side, which is 200 divided by 200 meters, which means that tan theta is equal to 1. To determine theta, we just take the inverse tangent of tan theta. Doing that to left hand side requires us to do the same thing to the right hand side to preserve the equality, so we also take the inverse tangent of 1, the right hand side term. This gives theta. Tan and inverse tangent actually cancel out, but that's a good way to think about it. Theta is equal to the inverse tangent of 1, which if you determine from your calculator will give you a value of 45 degrees. So theta, the angle of depression, is 45 degrees. Here's another example question, and it says Humpty Dumpty is sitting at point A on a wall 20 meters tall. So we have a vertical wall that's 20 meters tall, and Humpty Dumpty is at point A on top of the wall. I'm sure you guys have heard of the nursery rhyme. And there's an empty box located at point B on the ground. So here's our ground level. Now we have point B here. There's an empty box there that's 5 meters away from the base of the wall. So we call the base of the wall C. The distance between C and B must be 5 meters, just because point B on the ground is located 5 meters away from the base of the wall. The base of the wall is also on the ground. So all of a sudden, a strong gust of wind blows Humpty Dumpty from point A, so off the wall, into the empty box, where he breaks into a million pieces. The question just says, what is the angle of depression from point A to B? What is the angle of depression from A? So you're looking from A at point B. What's the angle of depression formed? What's the angle of depression? Well, the angle of depression is the angle formed if the observer at A was looking horizontally. It's the angle formed at the line of sight of the horizontal line of sight and the actual line of sight of the observer. So it's this angle here. So if I just form a rectangle, I get the following shape. Well, AC is 20 centimeters. If I call this point D, DB is also 20 meters. And since CB is 5 meters, AD is also 5 meters. Essentially what I formed is a rectangle because this here is a right angle and this here is also a right angle. So I just need to focus on the right angle triangle containing theta, which is this right angle here, theta here, 5 meters here. So this is point A, this is point D, this is point B, dB is 20 meters. So all we need to do is find theta. This is the opposite side, theta. This is here's the adjacent side because this is the hypotenuse. So O is equal to 20 meters. A is equal to 5 meters. So from SOHCAHTOA, we know that the tangent of theta is equal to the length of the opposite side divided by the length of the adjacent side. So the tangent of theta is simply equal to 20 meters divided by 5 meters, which means that tangent of theta is equal to 4 meters. Taking the inverse tangent gives, for an expression, inverse tangent of both sides gives this. So I'm just going to ignore the meters, and this results in theta being equal to the inverse tangent of 4, which from your calculator you determine that theta is equal to 75.96 degrees. So all you have to do is hit the shift key, then hit the tangent key, that gives the inverse tangent, and then just type in 4 and hit the equals to sign, and you get theta as 75.96. So that's the inverse tangent of 4 is 75.96 degrees to 2 decimal places. Here's another example question. It says, an eagle located at point B in the sky plans to capture a small fish located at point A on the surface of the ocean. So we have an eagle flying and it's in the sky. At some time instant, the eagle is at point B and is trying to capture a fish which at that same instant is located at point A on the surface of the ocean, the water, you know. The angle of depression of the fish from the eagle. So imagine an observer at the eagle's position looking downwards at the fish. The angle of depression is 60 degrees. Given that the horizontal distance of the fish from point C directly below the eagle is 5 meters, how high above the ocean is the eagle? It says we have an eagle at some point B in the sky and it's trying to capture some fish at point A on the surface of the ocean. So if I consider the surface of the ocean to be flat, I have this scenario. If I draw a vertical line downwards, I just get this sort of right angle, because you know you're always trying to form a right angle triangle for problems involving angles of depression. Anyway, the angle of depression of the fish from the eagle is 60 degrees. So line of sight from B to A is this line here. Well, let me just give a better sketch. Is this line here, this diagonal line here, that's the line of sight. An observer at B looking horizontally has this horizontal line of sight. Horizontal line of sight. And the angle formed between this horizontal line of sight and the actual line of sight is the angle of depression of the fish at point A from B. So we're looking from B. This is the angle of depression I'm going to call theta. Actually, it's been given as 60 degrees, so we know the angle of depression. I'm just going to complete this side by forming a rectangle. So we have the scenario here. We know that the horizontal distance of the fish from point C, so point C is directly below eagle actually, so this point should have been there. Let's put it this way. This is a hyphen which should have been here. So given that the horizontal distance of the fish is a hair, from point C, the horizontal distance is 5 meters. So point C is directly below the eagle, as you can see. And the distance between point C and A, the horizontal distance is 5 meters. We're asked to find the height above the ocean of the point where the eagle is. So we need to find how high above the ocean the eagle is. I'm going to call the height X. We need to find how high above the ocean the eagle is positioned. So we need to find the height of this point X. Now BC, if I call this point D, has the same length as DA because it's a rectangle. AC has the same length as side DB, which is 5 meters. So I'm just going to move to a neater diagram. So the eagle is located at this point B. the fish is located at point A. The point C lies directly below the eagle. And I'm going to call this height, so the length of B to C, X. So essentially we have a right angle triangle because there's a vertical line, vertical height, and this is the horizontal surface of the ocean. So we just focus on this right angle triangle, triangle ABC. We have a right angle triangle, but then extending point B horizontally gives this point here D, and extending point A vertically upwards to link up to the point D will essentially result in a rectangular shape. And we know that for a rectangle, opposite sides are equal, so the length of BC, which is X, is also equal to the length of DA, which is X. The length of AC, which is 5 meters, is also equal to the length of DB, which is 5 meters. And in order to determine the value of X, it is best to focus on just the right angle triangle involving the angle 60 degrees, involving the length X, and also involving the adjacent side to the angle 65 meters. Why? Because we're going to use SOHCAHTOA, and for SOHCAHTOA, you know that the tangent of some angle theta is equal to the length of the opposite side divided by the length of the adjacent side. The theta here is 60 degrees, that's our angle. That's the angle of depression. The length of the opposite side is this side dA, and the length of the opposite side is X. The length of the adjacent side is 5 meters. So, using SOHCAHTOA, the tangent of 60 degrees is equal to X over 5. Tan 60 degrees is the same thing as tan 60 degrees over 1. Cross multiplying, so I'm just going to use a different color. Cross multiplying gives 5 times tan 60 is equal to X times 1, which is X. So X is equal to 5 times tan 60 degrees. So I'm just putting tan 60 degrees in a bracket. So X is equal to 5 times, what's tan 60 degrees? Well, tan 60 degrees is the square root of 3. So I have 5 times the square root of 3. So X is equal to 5 root 3. And that's 5 root 3 meters. And that's the distance we're looking for. And if you want to simplify to give a decimal, well, X is equal to 5 times root 3, which if you do in a calculator, you'll get is equal to 8.66 meters.